Hello class, today I want to talk about seasonality and climate, or the Earth's position in space and how that affects our weather and our climates and our seasons throughout the year. So what we have to remember is the Earth is a sphere. There is a North Pole and a South Pole, and right around the center there is the equator. 93 million miles away out in space is the sun, and it is sending energy to us all the time. That energy is basically rays, and those rays will hit the Earth's surface at different angles. And notice where they hit the Earth directly, the energy is concentrated in a small area, and where they hit the Earth near the poles, the energy is spread out. So you get the same energy over a greater area at the poles, which is why the poles don't heat up as much. Now, the Earth is not straight up and down. It rotates on an axis which is tilted 23.5 degrees from the solar system's plane of the ecliptic. This means that at different times of the year, the sun is going to strike the Earth at different angles, depending on the sun's position around the Earth. When the northern hemisphere is tilted away from the sun strikes most directly at about 23.5 degrees south of the equator. This is an imaginary line, which we call the Tropic of Capricorn. You'll also notice that during this time period, when the northern hemisphere is tilted away, the sun never reaches the North Pole. So if you've heard that during the winter it never gets light at the North Pole, this is why. For the same reason, it always stays light at the South Pole during our northern winter. We would call this time of the year, we would call it the winter solstice, and this would be December 21st. And it would only be the winter in the northern hemisphere, because in the southern hemisphere it would be the summer. So our winter solstice is the southern hemisphere's summer solstice. Now, 6 months later, after our winter solstice, we've gone around to the other side of the sun, and our northern hemisphere will be facing towards the sun, which means that the area that the sunlight will be hitting most directly is going to be about 23.5 degrees north of the equator. It'll be hitting the North Pole all the time, and as you can see, it will never hit the South Pole, so the South Pole will be dark all day long, and the North Pole will be light all day long. Now, the place where it hits in the northern hemisphere during the summer solstice, the place with the maximum intensity of sunlight, is going to be known as the Tropic of Cancer. And then I'll go ahead and name the southern tropic. The southern tropic is going to be called the Tropic of Capricorn. And if you're in between these two imaginary lines that are 23.5 degrees north and 23.5 degrees south of the equator, you're going to be in an area of the world known as the tropics. And in the tropics, what that means is at some point during the year, you're going to get 100% direct sunlight. So now let's take a look at how our seasons change as the Earth orbits around the sun. So the Earth orbits around the sun once every year. And so it goes through 4 basic positions once every year. So at one point during the year, the northern hemisphere is going to be pointed most directly towards the sun, and at one point the northern hemisphere is going to be most directly pointed away. And then at 2 points during the year, the equator will be directly angled at the sun. And these are going to be called our equinoxes. So in December and June, these are our solstices, and then in March and September, these are our equinoxes. Equinox means the sun is directly over the equator, and the northern and southern hemispheres are getting equal sunlight. So you may be wondering, what does the Earth's position in space have to do with its climate? And the answer is quite a lot, actually. So we're going to draw the equator and the 2 tropics, and then we'll remind ourselves that 93 million miles away is the sun shining its intense radiation at the Earth, and that it's hitting the equator most directly for most of the year. And where the Earth is heated the most, that causes air to warm, and we all know that warm air rises. Now, the warm air that rises, it can't rise forever, and it eventually has to fall back to the Earth in a convection cell known as the Hadley Cell. The cells near the equator are known as the Hadley Cells. Now, the thing about rising air, it may be warm when it started, but as it rises, it cools. And as it cools, that causes water to condense, and that causes rain to fall. So cooling air forms rain, believe it or not. I think we all knew that already, actually. Now, if we move further on, we'll see that the air that's falling back down is dry. Why is it dry? Because it lost all its rain as it was on the way up. So the air that's falling down is hot and dry because sinking air warms up. So what does this give us? This gives us near the equator, it gives us rainforests. And about 30 degrees out, 15 to 30 degrees out from the equator, we start to get deserts. We get deserts where the hot, dry air sinks, and we get rainforests where the air rises up and rains. Now, I want you to recall that throughout the year, as the Earth moves around the sun, the area where the Earth is warmed the most moves northwards and southwards. It can move as far north as 23.5 degrees. This would be on the summer solstice. On the summer solstice, the area of the highest warming of the Earth would be 23.5 degrees north, and all of the rainfall and the dry and the wet and the warm and the cool would all shift northward on the Earth's surface. And then 6 months later, when the sun is most directly over the Tropic of Capricorn, then the most heating would be happening there, and that's where the most rain would be, and that's where, and all of those deserts and rainy areas, those would all shift southward. So just remember this, the rain follows the sun. So far, I've only drawn one set of convection cells, and those are called the Hadley cells. But there are two other sets of cells on the Earth's surface. One is in the mid-latitude, in the regions, say, where North America, Europe, or Southern Africa would be. These are known as the feral cells. And then finally, very, very far north and very, very far south, near the poles, we have what are called the polar cells. What's important to note is that wherever air is sinking on the Earth, we get dry climates, and where it's rising, we get wet climates. Now, these shift north and south with the changing of the seasons. During the northern winter, all of those shift northward, southward, and then during the northern summer, everything shifts northward. And where we have air rising up, it tends to be very wet. Air rises where the cells meet. So at about 40 to 50 degrees north, it's very rainy. 40 to 50 degrees south, it's very rainy. Along the equator, it's very rainy. Fringing the equator, we have deserts. And then all the way to the poles, it is also very, very dry. So if we review and sum this up, air rises where Earth is heated the most, and where air rises, we get lots of rain. About 15 to 20 or 30 degrees away from where the air rises, the air tends to sink back to the Earth, and this creates very dry conditions and deserts. These belts of rising and sinking air move north and south as the seasons change and as the sunlight hits the Earth directly at different latitudes. This gives us seasonal climates such as savanna, while maintaining areas like rainforest all year long.
I hope that helped.
And I do hope that helps. If you like what you've seen, please like and hit subscribe. Thank you very much. Have a great day.